for those of you that don't know me, Brian Blunt, and right now I am the engineering program. And before I get started on that one, it just reminded me of a little anecdotal piece of information I heard this morning, one of the reasons we do the program. There was a girl out in the hallway talking with her health teacher, and they were, overheard the conversation, so I just eavesdropped in, and she was asking him, about music class. Why do I need to know it? He said, well, you can appreciate music. I appreciate music. I know what I like and I know what I don't like. And the coach, his one PE coach, was doing a health class, and he told her, said, well, I'm not a musician, but said, I like to know a little bit about the music, why certain piece is written that way, or who wrote it, or some background on it. And she's like, I don't need to know that. And it just struck me. I said, that's the whole reason we do these classes. When we give that type of girl, she's not, and I asked her, I said, is she low performer? Is she lazy? She's like, no, she just doesn't understand why she needs music. And I said, I agree with that. Now, the whole purpose of the program is to give from the top kids like Joe and Kobe and all, like Ben and Heaven and your son, who are academically on the top of the list, to the kids who academically struggle. We give them a good reason and purpose for being in school. They are seeing that the courses we have, the subject matter we are teaching is relevant. They can walk out of high school with a set of job skills that can very possibly start them in a career when they're 17 years old. The bottom line is right there. It is a career path course. That is everything we're looking at doing for the kids. It's setting them up with the information, with the desire, with the drive, with the support from you guys at home, from us here in the schools, teaching them what to do and how to do it, so that they know the career path they choose. And whether that turns out to be at the 2-year associate level, if they want to go to a 4-year college to be a more traditional engineer, if they go into master's or PhD work, they have already decided at this age, at this level, where they need to be going. And now it's our job to help them track down the line to make sure that happens. So that, long and short, that could be the whole program scope right there. That's the purpose. But what we're going to do to make that happen, we got 3 things we need to do. I'm going to talk about each one briefly here in a moment. The program tracks, the business partnerships, and then finally what kind of courses we're going to offer. Now, they had a press release that was given out to the district personnel today. Now, I imagine it will be in the paper tomorrow. The press release is that the Texas Gas building, we have officially closed on it today, so it's district property now. And with that said, the press release, the next paragraph is that the Texas Gas building will be a regional technology center. And the discussions are already underway, and I've had my input in on that one. I've had many discussions with administrators, with teachers, with some folks up at UK when the conversation comes up, that we are looking at incorporating the Discover College, the community campus, all into that regional tech center so that we can offer these kids. Now, I don't know if this will be finalized and come to fruition, but the plan should be, and hopefully will be, that by the time they leave high school, they could have a 2 years associate's degree with AutoCAD drafting. They could pick up a 2 years associate's degree with mechatronics, which is a kind of a hybrid of engineering. You get to do a little bit of robotics, hands-on mechanical engineering, you get some electrical engineering behind it, and you also get some computer programming involved. So we've got a couple of engineering 2-year tracks. There are the biomed 2-year tracks that they can look at also getting their degree in, which, if we stop and reflect for just a minute, that makes perfect sense. You've got 4 years in high school. In the tech center, the idea, it should be a middle school to high school type school, serving about 300 to 400 kids. But in that high school idea, you've got 4 years of high school classes. You have 2 years you need to get an associate's degree. So the time frame is a perfect marriage for the kids. They go to that school all day long. They take their English, their math, their social studies, the core classes, and we spend the rest of the day teaching them the skills and the concepts they need to be an engineer or an architect or a CAD drawer or a biomed researcher, or perhaps going into RN or pre-med or pre-dentistry or pre-pharmacy. So I mentioned earlier, my son won't be taking robotics with me next year because he wants to be a dentist. But with this with the tech center coming online within a couple of years, he might be up there doing the biomed classes, which is exciting to do. But let me backtrack just for a minute. Right now, for the 8th graders and possibly the 7th graders, because logistically and physically it's going to take at least a year to get that building retrofitted and up to speed to have the courses we want in there. So most definitely for my 2 8th graders, you guys, the only option we've got right now for the program track is the community campus. What that is, it's dual credit classes. The kids, and I pulled up the homepage of the website for you guys. You can check it out online. Just Google Community Campus Owensboro. And the first hit will be this homepage. It's a very well laid out page that gives you the background of who they are, what they are, how you have to get into it. So the community campus is basically a dual credit institution. They work in conjunction with OHS, with the county school system, with the other areas, Muhlenberg, Hancock, and most importantly with the community college. The kids, they report to a designated area for their one class a day. The engineer kids would go to Apollo for the first block. The biomed students actually go out to the community college. And they've got tracks for drama, for the construction trades, and also for entrepreneurship. You know, my specialty and area of focus is the engineering and biomed, so I'm going to kind of keep it on that tangent. But they report to their class first thing in the morning. They take their class, the engineering and biomed class, then they are bussed back to their home high school for the rest of the day. Community campus is a very good setup for the kids that want to go and follow that track. The downsides of it right now, to get into community campus, you've got to have an ACT score of at least 17. Or you can take the Compass test, which is your community college entrance exam. The number requirements aren't exceedingly high. 17 is very doable, so is the Compass exam. But most of you guys, if you weren't here right now, you would not have heard of this until January or February when they have the parent meetings for community campus. At that time, you're struggling, you are moving quickly, you are stressing out to get those tests taken, scored, and back in time to get into community campus. So that's one of the downsides of that. Another reason that community campus is good, but maybe not ideal, for our OHS kids, it conflicts directly with some of their AP classes that they can take. It conflicts with some of the honors classes they can take. And there's also that band orchestra interference that can happen. So some of the classes that these kids want to take at OHS, they have to decide, and that's unfortunately what we did this year at the middle school. You had to decide engineering or drama, engineering or choir. That's still at the high school. You have to decide engineering at Apollo or AP World Civ. And you know, some kids do not want to have to make that choice, and they don't. They decide to stay at OHS and opt out of the engineering classes. So the community campus, again, nice option, especially if you are very interested in engineering or biomed, but there are some drawbacks to it. So I didn't get a chance to change this part of the slide, because up until this afternoon, I would have talked about the fact that OHS is going to be coming online within the next year or 2 years to ramp up our course offerings so that kids who are not interested in missing out on AP courses or missing out on a drama class in the morning, or just don't want to leave their friends that they've met and had for several years, they can take the classes at OHS. But now with the tech center coming online within 2 years, that'll be our home high school within the district. And I'm imagining the conversations will probably go for you guys that are involved in extracurriculars. You'll go to the Tech High during the day, and you'll head back to OHS for golf practice or track practice, swim practice, volleyball, whatever it might be, drama practice. So you'd still be involved in your extracurriculars through that avenue. That basically are the program tracks that are going on. So you've got the choices for engineering, for the biomed, and again, the exciting part, a couple years, we're going to have it in-house. Now, the second component of this is a partnership with the business and industry. And the big question, people say, okay, why do you need to worry about industry and business? One simple answer. These are the people that are going to be hiring our kids. Now, they do not drive 100% of the curriculum, but they are most certainly, I would say, a very close second to you parents. And being a parent of a student, I like to consider the parents the most valuable stakeholders in the kids' education. I mean, they're your children. I see them for a year or 2 years. You guys have them until you're in the grave. So you are the most important advocate that your kids have. Closely behind that, though, are these folks. If we don't try and work with them and find out what skills, what concepts, what new technologies they want to have introduced to the students, then we're going to be just simply an academic exercise. We'll be doing some nice classes, some fun classes. It'll make for good press. It'll be excellent for the kids to do, but it won't be relevant. So you've got to partner with our local industries and business. What I would like to see happen is not just to have the local engineers or the local computer programmers come in on a career day and talk about what they do, what type of degree they had and the path they followed, but actually set up some type of one-on-one mentorship. If I've got a kid like Joe who's interested in mechanical engineering, we find somebody Titan that we can partner up and they can mentor. They can pull Joe into their offices, out into their field offices, and he can see what they're doing on a day-to-day basis. He can see the type of software they use to design these components, and with the skill set we're giving him, I'm actually hoping to get some internships involved where the kids can go out and do work with the engineers and the drafters and the architects. They can sit down with their basic skill set they've developed here at school and tell this person, all right, I know how to do some auto inventor. These are some of the things I've done. And then they develop that skill set from there. So that's really one of the ultimate partnerships I would like to see. But basically, that's why we want to get business involved, because they are the ones that are going to help us decide what's really relevant, and they can help keep us on that cutting edge of being inside the business and the industries. They know what's coming down the pipe for their particular sector. So a lot of exciting, and there are a lot of hidden gems in the Owensboro area. People, you hear the word Titan, you might think of just local construction, but they are a global business. They have tons of mechanical engineering work around here. We've got MPD, who is one of the only companies in the nation that does radar devices. We have the Kentucky Bioprocessing. They're out there doing biomedical research on plants, looking for cancer research. And of course, we've got the Cancer Institute here in town. It's growing in reputation yearly. So we've got a lot of hidden gems that our kids can go intern at, work at, job shadow, go to the door and say, hi, I'm looking for a job in a few years. Is there something I can do in this building? And one of my functions would be to go up there ahead of time and make that contact. Say, hi, my name's Brian Blunt. We're running the engineer program over at Tech High. What can you do for our kids? Going to the Rooster Booster meetings, going to the chamber meetings, and just putting, just like we're doing now, putting our program in front of somebody's face and saying, do you know about this? Let me tell you about it. Anyway, I'm off on a tangent about that. In the business, there's a lot of good potential in that one. Now finally, the last component, course offerings, the meat and potatoes. What I gave to you guys when you came in, this is just a quick overview I put together over the summer. The courses I've listed on the front and back of the sheet, we work under the umbrella of an organization that's PLTW, Project Lead the Way. They are an easy relationship or an analogy. They're the Microsoft of tech education. So they are the gold standard that we're working with. As part of being in the PLT curriculum, there are some courses that they require us to offer so that we can be one of their fellows. What I've listed on here is a short listing of the required courses. This would be a typical track that they could start on in the 6th grade and continue on through up to their 12th grade year. For example, in the 6th grade, it's always going to be some type of introductory class. So the 6th graders, it's a semester-long class. They just get a little smorgasbord, a little bit of flight mechanics, a little bit of flight theory. We did a unit on buoyancy here just past week ago. We're also going to do some energy units where we actually make some solar cells. We'll do an automotive unit where we design and look at some of the internal combustion engine principles. So it's a smorgasbord for those guys. When we start getting into that 7th and 8th grade year, we're getting a little more specialized. The 7th grader is going to be taking design and modeling, which is 3D AutoCAD, Auto Inventor. The 8th graders will take a robotics course for the year. Then once we get into high school, we only have a couple classes we have to offer, and they're basic engineering classes. And Introduction to Engineering Design, which is a more in-depth AutoCAD type class, and we've got the Principles of Engineering, which is a more mathematically based basic engineering class. We start to really look at the physics behind why a catapult works. We will look at the mechanics of our dragsters that we build. Based on the wheel size, the gear ratios, the weight of the machine, we can calculate the actual speed of our scale dragsters. So we get more intense on the mathematics. Once we finish with the required PLTW courses, the offerings, we're going to have a lot of latitude. I would love to see, once we get the basic requirements done, for the kids that like drafting, they want to do AutoCAD, they can, again, I said earlier, they can focus on that AutoCAD for their 4 years and have that 2-year associates. For the girls and the guys who are looking at the mechanics, the mechatronics, they can focus on that basic robotics with computer programming, and they can get a 2-year degree by the time they're out of high school. For a kid that is interested in chemical engineering, obviously there's not a 2-year degree for that, but we can get a track focused for them so they can start learning some of the organic chemistry and some of the inorganic chemistry you've got to have, and actually know how chemical engineering is worked into industry. For the kids who are into biomeds, I have a 16 and a 17-year-old son. They're with my former wife down in Georgia. The high school they're in, my 16-year-old who's a senior, he will finish his senior year up with a CNA degree or a CNA certificate. And they have a health program. His whole focus is to get into nursing school and then go to graduate school for nurse anesthetist. So when he finishes high school, he'll have his CNA certificate. He'll have a 1.5 years of college credits done already. So I envision something similar. That's in rural South Georgia. My goodness, if they can do it, I know we can. So definitely, and that's what I can envision happening for us, are those type courses being offered. The requirements are done. And obviously, I'm going to back up a step with the course offerings. Obviously, we've got to have their basic core content. They've got to have X number of maths. They have to have Y number of English and social studies. So that's obviously going to be part of the curriculum up there. But when you're doing the engineering and the biomed, I mean, my gosh, the math and the science are so intimately wrapped in there. I mean, I could do a whole calculus course in principles of engineering, just figuring out how the stuff works. You can do a whole chemistry class in the medical detectives course. So, I mean, you've got their core curriculum wrapped into these career courses we're looking at offering. And even with your language arts, because they're already learning how to communicate, one of the things PLTW is not adamant about, but they really like to see happen, is for these kids to actually stand up and do a presentation to an industry insider. They've designed something, they've built it, they've remodeled it, they've re-engineered it, and it works, it solved a problem. They like these guys to stand up and say, here's something we have done and solved. So they've got communication skill there by the verbal and the written. So a lot of our core classes can be wrapped right back into what we're going to be doing at the Tech High, without a doubt. So with that said, I need just to, and I'm doing good on my time, I'm 16 minutes in. I've got about 5 more minutes. I wanted to show you guys some of the stuff that your kids are already doing. So I got a little smorgasbord here. The first thing up, the 7th graders, at the end of the year, what looks complicated and impressive to a parent, to a 7th grader, I'm hoping they're already seeing that's only about 8 different parts. So if they can make those 8 different parts and then put them together, you've got a model of Da Vinci's tank. So that's some of the stuff we'll be doing toward the end of the year. They get a little bit of that fun freedom. The 8th graders, one of our first automated robots is going to be the Clawbot. Very simple build. It's got 4 wheels. It's going to move around. It's going to be able to move certain directions based on the command we give it. And it will be autonomous. That means we'll program it, we'll step back, and we'll make sure it's doing what we program into it. But the idea of that one is going to move around, be able to pick something up. So now, the 6th graders, I get to bring their hands on stuff. This, Cameron, is something you might do next year in 6th grade. And I believe Megan, correct? She's a 6th grader. She'll do this next semester. What I gave the kids was and actually it was just a lot of leftover material I had. I came up, I said, let me give them this. And they had a cup, they had 5 sticks, they had some string and some tape. I gave them this smorgasbord and some 4 paper clips. Gave them this smorgasbord of stuff, and I said, design a structure that stays as tall as possible when you drop it. And this was one of the ones that stayed taller. When you drop it, oh, and I knew it. As soon as I say that, it turned over. Let's see, let me drop them again, because it has a nice little bounce in there. The way the sticks are aligned up, it has a spring action in it. And twice I dropped it for them. But when you dropped it, it had a little, oh, I see why. There. It had a little bounce in it, and it sprung and it stood up straight. So, I mean, they had to go through the 6th graders. The big focus in that class is design process. You have to come up with a solution given constraints and criteria. Then when it doesn't work, you have to be able to re-engineer it or redesign it. Then you test it and modify it and keep doing that process until you get something that works. And I bet $1 I'll mess up Alex's. This was the winning one. This stayed up 51 centimeters. So let's see, and let me see if I can drop him down. Yay. All right, you see what happened on that one? He stayed up. I mean, the kid came up with the idea to have the height. He taped a couple of the sticks together. Then he put a little tape on the bottom to keep it in place. And he had the idea for stability. And he's got these 4 sticks on the side that kept it from tipping over. He figured out when he dropped it the first time, he had the sticks on a cup. And it went down too fast. So he put his index, stability, strength, a really nice structure. So he's applied some excellent engineering principles in that one. One thing, Kobe, you guys in the 7th grade, you've heard me say you're getting ready to do soon. They will have a Freedom of Design project. They're going to be doing a playground sometime early November. And by freedom of design, I'll give them a couple of constraints. They're going to have monkey bars in there for me. They're going to have a slide, and I'll probably have them put a swing of some type in there. Aside from those 3 very generalized constraints, they've got the freedom to design anything they want. So we'll see, they'll sketch it out, they'll design it, they'll modify their design if it does not model very well, and we'll see what it looks like. Another thing the kids are going to do when we finish our chess set, we're going to look at a few more industrial applications. We'll actually build a couple engines. We might do a small ice cream freezer that I saw at Bluebell Factory this summer. And then the one I am having the most fun with, honestly, is the walking robot for the 8th graders. That is it's a fun little project, but the difficulty of getting a robot to walk, I did not know about it until I started doing it. So that's one option I've come up with right there. Now, and on my 6th grader, I've got one more. I have to show off this. In their flight unit, if I can get Baby Bug to work well. They're learning about principles of flight right now. So last week, we simply made some very thin foam gliders. And I told the kids this is basically for the grins and giggles. You make it, you take it home, you play with it, and you fly it. And now we're going back and we're looking at the principles, the 4 forces in flight. You've got your thrust, you've got your drag, your lift, your gravity. They're looking at airfoil designs. So there's a lot of very high level aerodynamics that can be involved in this little project. But let me show you what, I'll show you what Baby Bug does. There we go. Well, and I caught a little bit of turbulence on her. So, but this is what they're doing. They're sitting at home, and I'll have to be honest, I've walked around this building about 5 times, going up and down every hallway playing with them for a week. So that's one of the 6th grade projects in their flight unit. We might have a budding aeronautical engineer that comes out of that one when they start to say, that's cool, building planes. So, a couple more pictures from my 7th graders. I wanted to show you guys something. Within the first 5 days of class, they had already modeled that one. Now, when I say to Kobe, I'm like, oh, that's a simple extrusion. We did a 3x3 cube. We extruded a circle out 1/2 inch. We did the square out 1/2 inch, and we did a cut extrusion by, I think, 1 inch. All of that has meaning to him. So for the parents, it's like, what are you talking about? Well, they modeled a 3D cube. They pulled a circle out on his front face. They pulled a smaller cube out on that face, and then we cut into it by about 1 inch. And that was in the first 4 days. So, 8th graders, once we get done with the claw bot, we're going to make it into a chore bot. So you'll have that. Well, the idea is you've got a basic claw bot you design, then you're going to modify the thing so that it can actually pick things up, put it into a bin, and take it over to a designated area. So you'll have a design. This is something that happened, engineering all the time. I'd have a project, we'd take it to the customer, and they'd say, that's a great idea, but that's really not what I had in mind. I needed to do X, Y, and Z now. So from ClawBot, you get your customer's modifications, and you make it into a ChoreBot. And another example of an easy 7th grade build, this is something the guys, that's 3 pieces that they could put together right now within about an hour's time. And then we can animate that to where it actually snips, snips, snips. So let me summarize this on this one, and we will be open to questions. Basically, the whole program is set up. Even if they don't decide to go into a technical career, they are getting so many of the soft skills that employers desire. They're getting so many of the tenuous academic skills. I mean, for example, we're looking at making them into problem solvers. Because when they're in a class with me, I said, here's your supplies. Make it as tall as possible when you drop it. That was the only instruction they had. And you see 2 different designs that came up, and they worked. Now with the ClawBot, they'll be simply, I'll say you have to use 4 wheels, you've got to have a claw, make it work. And by the time they do that one, I'll have removed my picture from any of the other information, so it'll be a freedom of design. Engineers, we're always innovating. I mean, my gosh, I've got an iPhone 4, the 5's out on the market now. It's an innovation. That's where you are taking that product and you're making it better and better. That's the bread and butter for an engineer. And then for the few of us that actually get to invent something from scratch, brand new, And actually, you guys, if you follow the engineering track, the required 12th grade class, which could be an 11th grade class also, that one class you take in those last couple years, you have to sit down with your design partner, come up with some type of problem, design a solution for it, build it, test it, and then you will patent it. The news article a few weeks ago, it was about a month and a half ago, a couple kids at Apollo last year in this class, they had an idea for a modified earbud. So there was a problem. The earbud wouldn't stay in your ear well, so they modified an earbud design. They figured out how to make it. They built some prototypes. They tested them, and they have a provisional patent on that device now. So that is something you will do as a 12th grader if you stay with the engineering work. Biomed, they have some similar projects. It's just not a patented course. And of course, with all this said, they are most certainly self-reliant, because these kids that are in the 8th grade class, Kobe already knows, they are working a lot with the peers around them. It's not so much, Mr. Blunt, is this right? Mr. Blunt, is that good? Mr. Blunt, what do I do now? It's more they're turning over there and saying, is it any good? And they'll drop it and say, oh yeah, it worked. Yeah, they'll say, yes, it's good. Okay? I'm telling them, I'm teaching you the skills. Your job is to learn the skill and then have the confidence that when you're doing it, you know it's right. And to have the understanding that when something's wrong, you can maybe not know what's wrong, but you're like, that's not right, we got to figure it out. And of course, that leads right into the logical thinking part. And with all that put together, one of the soft skills that employers will love are when you guys are technologically literate. If you can go into that interview and you already know how to do PLC programming, if you've had some basics of robotics and you know how gears work and how robotic arms should function, you might not be an engineer. You might not have a 2-year degree, but you have a skill set and the ability to go to a job and work where you might be an operations manager. Perhaps you're a production supervisor. Maybe you are an analyst in the computer department. But all those skills will translate into a job for you so that you can support yourself, support your family, and be a productive citizen. So hopefully, with enough money, you might pay it forward by supporting somebody in a third world country when they're going on a medical mission. Or if you're an engineer, maybe you're going to Haiti and helping figure out how to build a water reclamation plant. So there's all kind of opportunities for that service with these jobs in mind. One last thing I want to show you guys is, if you don't mind, because I'm at 26 minutes, so I'm going to cut it quick. I wanted to show you our Facebook page, because the guys have mainly wanted to show you the 7th graders are going to start this project tomorrow, our animated chess set. This is what Kobe and his classmates are going to be making. They're going to, I've got the specs for them, so I'm going to give them dimension drawings that are the rook, the queen, the king, the knight, and a pawn, 5 pieces. They're going to model them, build them, put them onto a floating chess set, and then animate it. And no, there's no sound for this one, unfortunately. But that's what they'll be working on over the next 2 or 3 weeks. As they get their projects built, I will be posting their work on Facebook. And that was the model I did, by the way, just so I could put that one in there. So if you guys don't know about the Facebook page, it's my last name, Blunt, and then engineering classes. So you can follow in the 6th graders. I have their work on there too. Now that the photo opt-out forms are back in, I know who can be photographed and who can't. So I've got the kids in there, and I'm not mentioning all names, but I will show a face with their work. I'll mention, I say, good job, Kobe. Way to go, Joe. So you can have that proud mama moment and see the kids' work.